Is it clear audibility? If you are having this type of situation, what is the meaning of this? That means you have added bulk amount of water, excess amount of water. Then we say it is copper sulfate dot 5H2O, and this is, we write aqueous. Now this, see carefully, this is different, this is something different. Here we are saying that enthalpy of hydration is the amount of heat energy released when 1 mole of anhydrous salt is hydrated by addition of suitable amount of number of moles of water. On the contrary, if suppose for example I have taken copper sulfate and I'm adding water, right? There are certain reactions where you are having exothermic nature. There are certain reactions where you are having endothermic nature when the salt get dissolved. This is not dissolution. The first equation is not dissolution. I am now talking about dissolution. First equation is a part of the formation of anhydrous salt to hydrated salt. When you are having this type of discussion, then what happens whenever a salt is taken in a container? I have taken 1 mole of salt in a container, I am adding water. And I am doing experiments, say for example, using bomb calorimeter or any other instrument which can gives you energy estimation. So there is an apparatus connected and you are estimating. Add some amount of water, sir, energy released, suppose exo reaction. Add some more amount of water, energy released. Add some more amount of water, energy released. As your goes on adding water, there will be release of energy, but after certain stage of addition of water, you may observe that if you are adding water, even then the energy is not releasing, neither releasing nor absorbing. That is known as the enthalpy of solution. Enthalpy of solution is defined as the amount of heat energy released or absorbed, right? Enthalpy of hydration, the amount of energy released, always released. So enthalpy of solution is defined as the amount of energy released or absorbed when 1 mole, compulsory 1 mole of solute is added in such a large quantity of water so that further addition of water may not have loss or gain of energy. You have to add so much excess amount of water that further addition of water may not have release or absorption of energy. That is known as enthalpy of solution. And for that purpose, we don't write XH2O, number of moles we don't specify. We simply specify AQ. It means we have added bulk quantity of water. This is defined as enthalpy of hydration. This is known as enthalpy of solution. This is called enthalpy of hydration. Now, this is known as enthalpy of solution. But remember, we are writing like this, but in the container, what happens? First of all, copper sulfate will accept 5 water molecules. It will go to this stage, then it comes to this stage. It goes like this. First, we have formation of hydration, then we have formation of solution. But to understand definitions, we write like this. Suppose, for example, if I say copper sulfate dot 5H2O, and if I write here AQ, then copper sulfate dot 5H2O AQ. What is this? It is enthalpy of hydration of it is anhydrous copper sulfate. Whereas here also we can write enthalpy of hydration, sorry, enthalpy of solution. But this enthalpy of solution is defined as enthalpy of solution of hydrated copper sulfate. Therefore, how do we proceed for that? it is the amount of heat energy released or absorbed when 1 mole of solute is dissolved in excess of water, so that further addition of water why may not will not have exchange of energy. That is called as enthalpy of solution, right? Basically what happens, this is a Krishna Mohan sir's class discussion. Suppose for example, if I am having any salt available with me, say for example AB, then what happens? If it is added into water, once you are adding this into water, there are two stages. First, what happens? This salt gets dissolved, right? When you are saying it is dissolved, it will be something like this: AB aqueous, right? The amount of energy is supposed to be uh, of two processes, not one process, A plus and B minus, whether it's a strong electrolyte or weak electrolyte. That means here we are having two types of energies involved. One is called lattice energy, one is known as hydration energy. This is the amount of energy required to have lattice formation, right? And then we are having breaking of ionic compound into its individual ions. Then we have hydration process, right? Lattice energy is supposed to be endothermic process. Hydration energy is exothermic process. Therefore, depending upon who is going to dominate, inorganic people say, suppose for example, if lattice energy is dominating to hydration energy, it is endothermic formation of solution, enthalpy of solution. Let me write conclusions here. You might have done in Born-Haber's process all these things. Born-Haber cycle, right? What is that? Enthalpy of solution is equal to lattice energy plus hydration energy, not heat of head. This is different. Yesterday we have defined something known as hydration energy. This is okay. Next, there is one more last definition available here. ठीक है, और एक भी ले सकते हैं. ये सब बेकार की चीजें हैं, बट सिलेबस में इसका नाम है एंथैल्पी ऑफ ट्रांजिशन. What is this? It is the amount of heat energy released or absorbed when you are converting one electropic form of substance to other electropic form of substance, right? No one prefers to have this reaction, right? Science says that yes, if you are doing like this, suppose for example you have taken sulfur rhombic and you are converting to sulfur monoclinic. The amount of energy released or absorbed when 1 mole of one form of electropic form is converted to other form of electropic form is known as enthalpy of transition. Write down that. डॉक्टर का नाम नहीं ले रहा, छोड़ो नहीं, एक वक्त बोले काफी है, घर के सामने आके खड़े रह के पुकारना, डिस्टर्ब होता क्लास में, 10 वक्त बोले, फिर वहीं आके ठहर गए गधा। Muhammad Anas, please join in time better. Join in time and see the screen. It is slide number 1. ये कोई बात है, मैं ज्वाइन लेट हुआ, holiday, ठीक है, enjoy that better, enjoy that one. If someone announced that today is holiday, go, no problem, no problem. सुबह से क्या सो रहे थे? खैर चलिए कोई बात नहीं, आप लोगों को बोलना बेकार है। ठीक है बेटा, नो प्रॉब्लम, नो प्रॉब्लम। दिस इज स्लाइड नंबर 1. This is slide number 1. Previous slide is not available with me. This is slide number 1. स्लाइड लेके क्या सर पे मार लेते हैं? कॉन्सेप्ट समझ में नहीं आया, बोलते समझाते वक्त में सो के वहां के सर आई हैव जॉइन लेट. Who asked you to join late? It is your responsibility to inquire everything in the morning hours. Shall I proceed? Change your attitude. ABCD, thermochemistry, कुछ काम नहीं आता बेटा, कुछ भी काम नहीं आता. How you are learning, how you are behaving for studies, वो important है. ये सब कॉपर सल्फेट, सोडियम कार्बोनेट, ये सब बेकार है, ये कुछ भी काम नहीं आता. काम आने की चीज कोई और चीज है, वो है आपका एटीट्यूड, बिहेवियर, हाउ यू आर interested towards studies, that is important. Shall I proceed? Is it over? आप ही नहीं बेटा, अनस बहुत से हैं. मैं जब स्टार्ट किया क्लास 20 स्टूडेंट्स थे, अब 53 है. समझ में नहीं आता किसको भी, हाँ लिख लेते खाली क्या टाइम, क्योंकि आप में से 53 में से कई बच्चे टाइम पास के हैं, कुछ बच्चे हैं जो काम के हैं, वो लोग वक्त पे आते हैं, मालूम कर लेते हैं कब है क्लास, क्या है, वो सब आपकी रिस्पॉन्सिबिलिटी है. वो इफ यू आर ए स्टूडेंट, इट इज ऑल योर रिस्पॉन्सिबिलिटी. Is it over? Next. There is one more last discussion required, that is resonance energy. I hope you know what is resonance energy. I don't want to waste your time. It is very important. This all you have done in case of GOC, right? and especially you might have been discussed the benzene and resonance energy. Here in physical chemistry, if suppose it is not over, I'll explain all of those things. But now, since you have already done GOC, you might have enjoyed the concept of resonance energy. In our classes, we proceed like this. Resonance energy is any enthalpy of formation, enthalpy of combustion, enthalpy of reaction. Basically, we talk about enthalpy of reaction minus enthalpy of reaction. Remember, there are two types of enthalpies we discuss. One, experimental value, one, calculated value. What is experimental value? Experimental value is the value which is given. Enthalpy of formation of benzene is minus something, XYZ. This is called experimental value. Then what is enthalpy theoretical value? Calculated value means he will give you bond energy, he will give you enthalpy of formation, and you calculate the enthalpy of formation. If you are calculating the enthalpy of formation, that is called calculated, that is called theoretical value. Whereas if suppose he has given in the question, that is called as experimental value. Difference of this is known as the resonance energy. Remember, always experimental value will be less. Experimental value will be always less. Theoretical value or some people say calculated. What we are doing in the class, that is calculated. This is always less and this is more, therefore there will be negative answer, right? Go back to organic classes, what we have said there, that resonance energy is the amount of energy released when we are discussing about stabilization through canonical forms, stabilization through resonance formation, right? Delocalization of pi electrons. We'll discuss only this much. However, if you want to understand the background of resonance, today evening, revise the notes of resonance and come back here. We can enjoy that one. That is the end of what are the types of enthalpies we have discussed. Last but not the least, let us talk about one more thing. Suppose, for example, you are saying, sir, I am having a chemical reaction. In the beginning of the class, I'm going back. In the beginning of the class, I said, suppose, for example, you are having A plus B gives you C plus D. Whenever you have chemical reaction, a thermochemical reaction should be given by indicating some number, something like this, right? Here you have to say, sir, it is supposed to be solid, right? Say for example, it is gas, say for example, it's something like this. If you are indicating the physical states and also electropic modification, suppose you have written carbon, on that day what we have said, sir, carbon I have taken as graphite. If suppose you are indicating the nature of reactants and nature of products, physical state of reactants and products, and what? Electropic modifications available along with amount of energy released or absorbed. This is called thermochemical equation. Now for a thermochemical equation, if you want to calculate the delta H, suppose for example, I want to find out the value of delta H, then what I have done, here I am having reactants, here I am having products, right? Rule number one is converting reactants to products, and the amount of energy is supposed to be, say for example, capital Q, something like this, right? Plus I have said here, right? No, rule number two has taken reactants to something A, and then to dash. What we have two steps he has done. This is, say for example, Q1. This is, say for example, Q2. Roll number 2. He said, no, sir, I'll enjoy like this. This is, say for example, Q3. Say for example, Q4. Say for example, Q5. Then what we are discussing? Enthalpy. Go back to thermodynamics chapter. Enthalpy is a state function. It is independent of path chosen for the conversion. We are changing the path. Therefore, whenever we are discussing this, then we'll say, sir, total amount of heat energy released must be equal to algebraic sum of all the energies, whatever be the path chosen, whether you are going by direct path, whether you are going by indirect path, whatever be the case, remember that the amount of energy released or absorbed must be a constant quantity. What is this? Summation of heat is constant. What is this? Summation of heat energy is constant. And therefore, for this purpose, they have given the word. What is that? Hess law. Don't read as Hess's law. Hess law of constant heat summation. It is known as Hess law of constant heat summation. Okay, whatever with the energy. Let us just enjoy one example. Suppose, for example, rule number one says, sir, I want to have combustion of carbon. What is that? CO2. And once you have combustion, he said, sir, I have done this reaction directly. No problem. What is delta H? Delta H is equal to minus 94 kilocalories. Value is not necessary for you. Rule number two say, no, sir, I'll go carbon plus half mole of oxygen so as to give you carbon monoxide. Delta H is equal to minus 68 kilocalories. Carbon monoxide again made to half mole of oxygen. In 2 steps he is doing the same reaction, but 2 steps. It is found to be minus 26. Right? Decimals are there. I am avoiding. I want to enjoy concept. Right? This is how much? Minus 94 kilocalories. That means total amount of heat energy lost or gained during a chemical reaction is a constant quantity, irrespective of path chosen for the conversion. It is known as Hess law of constant heat summation. Take down that. Is it over? Yes. Fine. Ja. Jafar, please try to write down fastly. Over? No. That is the end of thermochemistry. Today, sit at home, revise the concepts very systematically. All take a paper and write down all the expressions and the concepts, the definitions, main concepts. Try to revise them. Come on. Question number 1. For the reaction, NH2Cl, try to write down along with me problem. When I'm explaining, see the screen, don't write at that time. Plus 3/2O2 gives N2 plus CO2 plus H2O. The heat released using bomb calorimeter is found to be minus 742.7 kilojoules per mole at 25 degrees centigrade. Find the heat of reaction. At constant pressure. At 25 degrees centigrade. Now, this is the first basic discussion I am starting. I am classifying the problems in terms of what we have learned in the sequence. Whenever we are having this one, remember that we have said number of things in terms of enthalpy, but the people, examiner and book authors, they use the word heat of reaction. Scientific language is enthalpy. But when we use the word heat of reaction, there is a possibility of twisting the question. So they like this word. Scientific word is enthalpy of reaction. They should say like that, enthalpy of reaction. But why is we are saying so? Whenever you are saying the word heat of reaction, this is of two types. Heat of reaction is measured at constant volume. Right? We have done this in the previous classes. When you are saying constant volume, you have to fix up the piston at constant volume. And remember that this is done by an instrument which is called as bomb calorimeter. Bomb calorimeter is a device which is used to measure the heat energy released or absorbed during a chemical reaction. Just now I said that roll number 1 has taken 1 mole of solute and he goes on adding water and he is measuring how much amount of energy released. How he is measuring? Using this instrument known as bomb calorimeter. Bomb calorimeter is always functioning in terms of constant volume. Therefore, The amount of heat energy which is measured at constant volume is given by letter QV. Go back to thermodynamics. You said, no, sir, QV is equal to del E. And we said one more thing, which is, of course, not necessary now, NCV del T. This is useful in case of thermodynamics, but this QV is equal to delta E. But once this fellow say delta E, it will be very simple. Examiner or author, del change of internal energy, nice. But they say, no, no, heat of reaction at constant volume means he is talking about delta E. Similarly, you can also measure this at constant pressure. Right? This is not done by bomb calorimeter. We use this and find out, then we'll go here. And what is this enthalpy, heat of reaction at constant pressure? QP. And what is QP? QP is equal to del H. Right? Enthalpy of reaction is nothing but the heat of reaction at constant pressure, because in the surrounding, in the lab, we are having constant pressure. If nothing is mentioned and he is giving heat, it must be always at constant pressure. For amount of heat energy released or absorbed at constant volume, the examiner has to mention, you have to mention it. Otherwise, we can't say constant volume, because constant volume is our applied condition. Constant pressure is natural condition. So suppose he is saying bomb calorimeter, he is indicating directly go to constant volume. If he is saying nothing, simply heat released, no word is given, it means it is constant pressure. And in previous classes, we have done something. What was that? Del H is equal to del E plus del N RT. This we have specified something. What we said? Gas. Change in number of moles of products and reactants, but they must be always in the gaseous state. I am doing problem with this first equation of thermochemistry. Come on. With all this understanding, clear, everything is clear on the board, on the screen. Come on, how to proceed? Very simple, sir. We are having delta H is equal to del E plus del N RT. Come on. Del H, my job. Del E is given using bomb calorimeter. What is given? Minus 742.7 kilojoules, take care of units, plus delta N, NP. This is always gas, number of moles of products. Water should not be counted. CO2, yes sir. N2O, yes sir. Check up, is it balanced or not? There are 2 nitrogens available, there are 2 hydrogens available, 2 plus 1, 3 oxygens, nice. Now if it is so, total number of moles, how do you proceed? Total number of moles of products is equal to 2 minus, this is gas to be counted, solid, no, it should not be counted, because this equation has been derived from PV is equal to nRT. So number of moles, 3 by 2. R, what is value of R? 8.31 for joule, 25 by 3. No sir, it is kilojoules. Therefore 25 by 3 or 8.314 into 10 power minus 3 into temperature. Temperature must be always in Kelvin scale. What you are getting? Along with sign, you should write as kilojoules. Go ahead. Is it over? Fine. Answer is minus 741. Yes, very good, very good. Minus 741. Who is this boy? Abrar. Very good. Anybody else? Anybody else? Writing of all these things is not necessary. Getting the answer is important. Getting the answer is important. Minus 740. 1.46 kilojoules. Very good, very good. Excellent. Raif Ahmed, Saidur Rahman, Abdul Wasir. Very nice. Done. Zaid. Excellent. Come on. Let us come to question number 2. The heat released on combustion of 7.8 grams of benzene. 7.8 grams of benzene is burnt. I am writing in other language so that you can understand easily. The amount of heat energy released is 327 kilojoules. He has given 327 kilojoules, right? Remember that positive sign he has given. Full stop. This heat has been measured using bomb calorimeter. Okay. At 27 degrees centigrade. Find heat of combustion of benzene. Find heat of combustion of benzene at constant pressure means enthalpy. This is the question, right? Now the explanation already over and you people are genius. Therefore, let us go. Combustion C6 H6 plus oxygen gives you carbon dioxide plus water. 6 carbons available, 6 hydrogens also available. 12 plus 3, 15 by 2. I should write like this. And then I should say this is a liquid, this is gas, this is gas, and this is liquid. Now go for that. But there is a problem. What is the problem? The problem is he's saying 7.8 grams and he's asking enthalpy of combustion. What is enthalpy of combustion? Enthalpy of combustion is the amount of heat energy released when 1 mole of substance, 1 mole. Therefore, what I do, del E, that is bomb calorimeter, for benzene is for 1 mole. What is molecular weight of benzene? 78. 7.8. Okay, that is, you people are genius. Why to calculate directly? I'll write it down. That is supposed to be 3270. This is kilojoules for 1 mole. 7.8 grams and 78 grams. Now I can use del H is equal to del E plus del nRT. Del H, my job. Del E, what is del E? Minus 3270. Why? Enthalpy of combustion. यहाँ पे आपको ये तकलीफ देगा, घुमाएगा. Psychological game is written in this manner. Enthalpy of combustion is always positive, negative quantity. चलिए, number of moles of gaseous products are 25 by 3 kilojoules, 10 power minus 3 into temperature. What is temperature? 300 kelvins. Go ahead. Saidur Rahman is saying minus 3261. No, 3273 he is saying. Answer is minus 3273. वहां से चेक करो कैलकुलेशन में कुछ गड़बड़ करें आप. थोड़ा बहुत डिफरेंस अगर है तो ठीक है, ऑप्शंस में आप चेक कर सकते, लेकिन 73 को 61 नहीं बना सकते, कहीं आप एडिशन में गड़बड़ हो. यस, यू आर राइट. 3273. Muhammad Rabba. Yes, correct. 3 students got the answer. That is average required for me. That means your speed should be according to these 3 students. Go ahead. Next. Question number 3. Find the value of delta H and del U. He's saying del H and del U. Del U is nothing but del E. For reversible isothermal evaporation of 90 grams of water at 100 degrees centigrade. At 100 degrees centigrade. Assume that water vapor behaves ideally, right? Assume that water vapor behaves ideally. It's assumption. And he has given heat of evaporation of water. Heat of evaporation of water is 540 calories per gram. That's all. That is a question, and this is a road key question, IIT question. Come on. How to proceed, doctors? This is not IIT means it is a higher level. It is a simple question, suitable for you also, right? Come on. First of all, what I have to say, heat of evaporation of water. What is the meaning of that? H2O I have taken in the form of liquid, and there is a reversible process. Yes, exactly at 100 degrees centigrade, this process takes place. 100 degrees centigrade. And it should be close that. Okay, done. Very good. Now, if we are having this, then isothermal, but there is a problem. Suppose, for example, I'm asked to, like an examiner, if someone asks me to create question and I have created this one, I'll give first option 0. First option 0, 0. Why? You are having one concept, sir. Isothermal processes is supposed to have 0 delta E, 0 delta H. Yes, we have done it. But here in this case, sir, ऐसा कैसा? कभी कुछ बोलते, right? Do you have any scientific way, or is it magic? And that class you said that the boys remember in case of isothermal processes and always delta E is equal to 0. Work is done, but delta H is equal to 0. For that purpose, you have given some equation. D of PV is equal to 0. Are you able to recall all the things? Yes, you should recall. You should recall. Otherwise, you are not attentive at home and in the class. Now today you are saying, sir, no, we have to calculate. What is the problem? The problem is, yes, delta H, delta U are of course 0 in case of isothermal processes. But here it is isothermal process with phase change. Are you able to understand? Liquid to gas. There is a phase change. Jaiye physics class mein kya bole the? Latent heat of vaporization, right? They use the word latent heat of vaporization. Kya hoga? I have taken a beaker in which I am having water and thermometer. I measured 25 degrees centigrade. Now room temperature. I have taken a burner and kept below that one and started gentle heating, slow heating. What I'm my observation, the reading of thermometer gradually increases. 90, 95, 99, 100. After that, it remains the same. Right? I have not removed the burner. I have not put it off. The burner is on, energy is supplied, but the energy has been used. Thermometer is not showing this one. It does not mean the thermometer is not working after 100. No, it's also perfect thermometer. What is the problem? Sir, the extra amount of energy, which we are supplying and not shown by thermometer is used by some other process. What is that process? Phase change. Therefore, physics people say this is the amount of energy hidden, छुपी हुई, latent का मतलब hidden energy, right? It is hidden inside so as to have phase change. अब एक नया चीज क्या सीखे आप? ये एडवांस का क्वेश्चन है. Delta H and delta U is equal to 0 in all thermal processes if there is no phase change. If there is no phase change. Wherever we are having phase change, remember that delta H is different, delta U is also different. They are not equal to 0. Enjoy the beautiful point today. Okay, nice. A very beautiful statement we have taken that is to be written in the notes. Come on, अब क्या होगा? Very simple, sir. He is saying heat of evaporation. What is heat of evaporation of water? It is enthalpy, because heat of evaporation is at constant pressure. Whenever you are doing this process in the lab, what is the pressure? Constant pressure. यहाँ कुछ नहीं दिया, देखो पिछले दो के problems में he is saying bomb calorimeter. Now he is not saying anything. इसका मतलब ये क्या चीज है? Delta H, del H, right? Del H is equal to 540 calories per gram. No, sir. No, sir. It is 540 calories for 1 gram. We never measure del H for 1 gram. We measure for moles, right? Therefore, 90 grams of water. What is total amount of energy? Total amount of energy will be dash. For 1 mole, 540, right? No, sir. We are having grams. तब क्या करेंगे? इसको बजाय ऐसा करने के हम क्या करेंगे? यहाँ पे इसको 540 into dash. अब क्या हो जाएगा? When you are saying 540 calories per gram, multiply by this number. When you are talking about sir 90 grams, बाज लोग ऐसा करते हैं, बाज लोग उसको चेंज करते हैं मोल में, तो मैं नॉर्मल ऐसा कर ले रहा हूँ, राइट? अब क्या बोलेंगे इसको? दिस इज डेल एच फॉर होल रिएक्शन. डेल एच फॉर होल रिएक्शन. चलिए, रिमेंबर दैट दिस इज फॉर होल रिएक्शन. अब क्वेश्चन क्या है? ये तो हो गया, एक आंसर हो गया आपका, राइट? दूसरा आंसर क्या होगा? डेल ई प्लस डेल एन आर टी. यहाँ एक ब्यूटीफुल एंजॉयमेंट है. ये क्या है? 540 इंटू 90 इज इक्वल टू, अच्छा ये माइनस होगा प्लस होगा? प्लस होगा सर, बिकॉज वी हैव टू सप्लाई एनर्जी सो एज टू हैव कन्वर्शन ऑफ लिक्विड टू गैस फॉर्म. डेल ई आपका जॉब है प्लस, चलिए, राइट? अब यू पीपल आर जीनियस, जल्दी से बोलो व्हाट आई शुड राइट. डेल एन, जल्दी. Enjoy the beauty of subject. What I should write? One zero. चलिए आते जाइए. People are saying 1 and 0. 1 Zahiruddin 1, Saeedur Rahman 1-0. चलो ठीक है. Very good. आप कोशिश करें. I am very happy. Right? स्टूडेंट हैं आप, नो प्रॉब्लम. गलती करना आपका हक है. चलिए, डेल्टा एन टोटल नंबर ऑफ मोल्स ऑफ प्रोडक्ट्स ऑफ गैस 5 माइनस 0. अब कुछ समझ में आई बात? क्या गलती हुई आपसे? 90 grams. आर यू फॉलोइंग द पॉइंट? यू हैव टेकन 90 grams. आप जो इक्वेशन बोल रहे हैं 1 मोल के लिए, यहाँ जब मल्टीप्लाई कर दिया आप 90 grams, इसका मतलब यहाँ 90 grams है, यहाँ 90 grams है. ये नंबर ऑफ मोल्स. आर यू एबल टू अंडरस्टैंड? 5 minus 0 into R. What is R? What is that? Calories. 2 calories into temperature. What is temperature? 373. बात समझ में आई? 5 की. चलिए, delta E is equal to, go ahead. ऐसे चीजों को एंजॉय करना. यस सर, टुडे वी हैव लर्न समथिंग न्यू. जो लोग वन बोले वो तो मेरे को बात समझ में आई, लेकिन जीरो कैसा बोले वो समझ में नहीं आ रहा. How, what, on what basis you said जीरो कैसे लाए बेटा? हमको क्लियरली समझाया गया क्लास में कि लिक्विड्स को नहीं नहीं काउंट करना है. अनस, ध्यान पढ़ने पे दो बेटा, ध्यान पढ़ने पे दीजिए. हर चीज क्लास में आती है, आप किधर रहते पता नहीं. सब कल हो गया था, कल बोला मैं आपको एज यूजुअल वी आर हैविंग क्लास, सब बोला हूँ. आप किधर रहते कि आप अननेसेसरी पूछ रहे हैं कि कल का क्या किस्सा है. आज तो, आज का तो कम से कम पढ़ो. पढ़ते हो तमाशा करते हैं, बाद में पूछते हैं. जहीर, I didn't got why we are multiplying 540 by 90. You are not able to read the problem, beta. Please read the problem. Black letters. Write the problem. Read it. Read it. और 540 के साथ यूनिट्स को रीड करो बेटा. कैलोरीज, व्हाट कैलोरीज फॉर हाउ मेनी ग्राम्स? 1. And how much you have taken? 1 chocolate 10 rupees. 2 chocolates, what to do? Multiply by 2 or divide by 2? ध्यान 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 चाहिए बेटा, ध्यान चाहिए. फिजिकल केमिस्ट्री में इंटरेस्ट चाहिए. कम ऑन, हरी अप, हरी अप, हरी अप. जल्दी लिखो. आई एम हैविंग अनदर क्लास. थोड़ा ध्यान बढ़ाइए बेटा, समझ में आता है. इतना एक्सपैंडेबल वे में बता रहा हूँ. आई एम नॉट अप्रिशिएटिंग माई सेल्फ, आई एम नॉट ए गुड टीचर, बट सब खुला है सामने. लेकिन फिर भी आप वो टेंडेंसी क्रिएट करो सोचने की. यस आई विल डू इट. लेट अस थिंक, लेट अस थिंक. 44870, वेरी गुड. Saidul Rahman, yes, you're right. That will stop here. The next class will be on Monday. Right, as usual. Routine जैसा है वैसे ही होगा as usual. उस अगर आपको संडे सैटरडे होना है तो जरूरत है तो ले सकते थे, अब जरूरत नहीं है. Because this Sunday I think we are having only inorganic parties there. So we'll meet again on Monday, inshallah. Assalamu alaikum. All about exams and everything, please discuss with your in charge person. I don't know anything. All right. Okay. अगर आपके एग्जाम है तो छोड़ देंगे, क्लास छोड़ दीजिए, कोई बात नहीं. No problem. It's their job to check the timetable and their job to. But मेरे को क्या होगा बेटा, मैं आराम से सो जाता हूँ घर में. नुकसान किसका हो रहा? आपका हो रहा. आप आईआईटी के एम्स के स्टूडेंट हैं, आईपी के स्टूडेंट नहीं हैं. आईपी होते रहता. आईपी एक सेकेंडरी चीज है आपके लिए. आईपी, वो आईपी का नाम लेना आपके लिए क्राइम है मेरे हिसाब से. ये मेरा अपना ओपिनियन, पर्सनल ओपिनियन है. लेकिन आप लोग शायद पढ़ते नहीं होंगे, इस वास्ते कॉलेज वाले आईपी करो, आईपी करो. चलो ठीक है, कोई बात नहीं, नो प्रॉब्लम. If they say there is a class, I'll continue. If they say no class, I'll sleep. No problem.